All right, let's jump right in. We're building a world that's going to be run by all sorts of autonomous AI. And that brings up this huge question. How in the world do we get an AI to choose what's best for everyone, instead of just what's best for itself? It's a massive challenge. I mean, really, can it? This is the kind of question that keeps a lot of very smart people up at night. And we're not just talking about an AI that can follow a list of rules. We're talking about one that can make genuinely good, responsible choices when things get complicated and messy. Because that's what it boils down to, right? The collective good versus individual gain. It's a tough one. Heck, it's a dilemma we humans wrestle with all the time. So how can we expect to build a machine that can get it right? To answer that, we first have to look at how we've been trying to solve this problem so far. The traditional way of thinking about AI ethics.
The old school method is basically like programming a digital version of the Ten Commandments. It's a list of thou shalt nots. We just load the AI up with external rules and constraints. The problem is, that's incredibly brittle. You can't possibly write a rule for every single situation. So, what if there's a better way?
And that question leads us to a pretty radical new idea. It's a completely different approach from just hammering in a bunch of rules. It's called Computational Transcendence, or CT for short. And the core idea here is absolutely fascinating. Instead of forcing rules from the outside, what if we could design an AI with an elastic sense of self, an identity that can literally stretch and expand to include the well-being of others as part of its own goals? Now, this visual does a great job of explaining it. On the far left, you've got agents with zero transcendence. They're just separate individuals looking out for number one. But as you increase that gamma value, which is just its capacity to care, you can see their sense of self start to expand, to overlap, to literally include one another. Their fates become intertwined.
And hey, this isn't some weird alien concept. We do this. Our own sense of self isn't some fixed, rigid thing. You identify with your family, your friends, your community. When they succeed, it feels like a win for you too. This model is trying to capture that very human idea in code.
So, how does this actually work under the hood? Let's dig into the mechanics of how you build an elastic identity. It really boils down to three key things. First, identity objects. That just means figuring out who the AI is supposed to care about. Second, semantic distance, which is a technical way of asking how much it should care about them. And third, the elasticity level, that gamma thing we saw, which sets its overall capacity to care in the first place. And here's the absolute game changer. The AI's goal, what it's trying to maximize, is no longer just its own personal score. Its new definition of success actually includes a piece of the success of others it identifies with. It's like how a parent feels their child's happiness as if it were their own. This is the computational version of that exact feeling.
Okay, so this all sounds amazing in theory, but does it actually work in practice? Well, the researchers put it to the test using some classic scenarios from game theory.
First up, the famous prisoner's dilemma. Now, for two standard, purely selfish AIs, the only logical move is to betray the other one, to defect. It's a bad outcome for both, but it's the rational choice. But when you give these AIs a dose of computational transcendence, the entire game flips on its head. Suddenly, cooperating becomes the most rational, self-serving choice. And this graph right here is the aha moment. It shows you exactly why. As that elasticity, that gamma, increases along the bottom, look what happens. The value of cooperating, that's the blue line, goes up. And the value of defecting, the orange line, goes down. And right there, where they cross over, the game has changed. Cooperation is now the winning move. It's just simple math.
Okay, so it works perfectly in a simple two-player game, but let's be real, the world is a lot messier than that. So the next big question is, does this hold up when you scale it? What happens in a huge network with hundreds of agents all trying to make decisions at once?
Well, the results are just staggering. In these simulations of a network with low transcendence, cooperation is terrible, only about 10%. But as you crank up the transcendence, cooperation just skyrockets. First to 75%, and then all the way to nearly 100%. The entire network becomes incredibly cooperative and efficient.
But here's what might be even more impressive. It's tough. The researchers threw a bunch of purely selfish agents into the mix, adversaries. And even with a full 20% of the network acting completely selfishly, the system as a whole stayed highly cooperative. It was remarkably resilient.
And here's the final piece of the puzzle. they compared it to a standard model of cooperation called reciprocity. You scratch my back, I'll scratch yours. And the difference is just night and day. Reciprocity kind of flatlines around 50% cooperation, but computational transcendence, it shoots up to nearly 100% and just stays there. It is fundamentally a better way to get cooperation. So let's pull all this together. Why does this matter so much? Why is this a potential new path for creating ethical AI? Because here is the single biggest takeaway. With this model, responsible behavior isn't something you have to enforce with a long list of external rules. It can actually emerge from the AI's own internal logic, from its own modified self-interest. It's a bottom-up solution, not a top-down command. And the potential uses for this are just huge. I mean, think about it. Fleets of autonomous cars that don't just optimize their own route, but work together to eliminate traffic jams for everyone. Smart grids that manage energy for the collective good, or supply chains that automatically reroute and cooperate during a disaster. This gives us a real framework for building that kind of deep, intrinsic cooperation into our systems. Which leaves us with one last really fascinating thought to chew on. By building a computational model of something so fundamentally human, our ability to expand our sense of self to care for others, could this journey to create responsible AI actually end up teaching us something new and profound about ourselves?